Okay, everybody. Turn to part 3, worksheet, what is this? Worksheet 2. Yeah, part 3, worksheet 2. There's a little table there, and it says on the table, well, see, here's the problem. On the previous page, it has the 3 columns described as subatomic changes, changes to overall atom, and it says in parentheses, yes or no, and then if yes, how does it change? So the back page, the back of the back page of worksheet 2 does not have those column headings at the top of the table. Those column headings are on the previous page, the ones I just read. So that third column that is blank boxes, you're supposed to be describing in those boxes how the whatever it is changed. So they're asking about the element name, the position on the table, the charge, the mass. You're supposed to explain then in that far right column how it changed if you said yes to those. So on to the first part. If you add a proton, does the element name change? Oh, come on. Oh, this thing's not writing. Jiminy Christmas. Answer, yes. Oh, geez. You know what? Oh, my gosh. This may be the worst situation I have seen for this. Oh, my gosh. Yes. Yes, the element name changes. Whatever it changed to. I don't know what you had in yours. Does the position on the table change? Yes. Now, the question, how does it change? Well, the position on the table, it either shifts to the right when you add a proton, or it does what? Goes down to the next row. So it's going to shift to the right, or it's going to go down to the next row. And charge. Does the charge change for the proton? Oh, I should have, oh my gosh. I wonder if I can grab this. I wonder if I can grab these right here and move. Oh, look at that. How neat is that? That's pretty neat. So this is for proton. And I'm going to put it red because that's what it was on the little build an atom thing. So proton, oh my gosh. Proton, again, yes, yes. And next. What did I ask for? Oh, the charge. Does the proton affect the charge? Yes. Now, the question, how did it change the charge? When you add a proton, it became more what? More positive. I'm just going to put a plus sign because this thing is terrible writing. More positive. Oh my gosh. There, became more positive. And let's see what's next. And did it affect the mass? Did adding a proton affect the mass? Yes. And what happened? Well, it became more massive. So it increased by what? Increased. This is terrible. Increased. That is so ridiculous. Increased by, oh my gosh, by 1. That's a 1. Increased by 1. Jiminy Christmas. All right, that was for the proton. Next, if you remove a neutron. Remove a neutron. Oh boy. Oh, hold on. This was for add proton. Add proton. Okay. Remove. This is so slow. Remove. I just have to talk slower. Neutron. Run. That's ridiculous. Okay, so what happens with the neutron? Does the element name change? No. Does the position on the table change? No. Does the charge change? No. Does the mass change? Yes. And what happened to it? Decreased by 1. Hopefully you saw that it decreased by 1. I'm not even writing the words because it takes too long. All right, now what's the next part? Remove an electron. Remove remove electron. Oh my gosh, this is awful. Remove electron. Okay, and the element name. Did the element name change? No. No. Oh my gosh, no. Did the position on the table change? No. Did the charge change? Yes. What happened? It became less negative. Oh my gosh. Less negative or more positive. Depends on what you had in there already, right? It could become less negative or more positive if you remove an electron. And did the mass change? No. I should probably put lines here to kind of separate. Oh boy. Oh, no, that's in the wrong place. Erase. Can I erase that? Okay, try it again. There we go. And lastly, finally, I'm going to, oh gosh, separate again. Hold on. Wait. Oh no. Black ink, black. Okay. And let's go with that. And we are, oh no. Add I'm just going to say add E for electron. And I got to save time. The bell's about to ding here, and I'm not even done with this. Oh gosh. Does it change the name? No. Does it change the location on the table? No. Does it affect the charge? Yes. And how did it change the charge? It became more what? Negative. Or less positive. And did the mass change? No. Okay, so I hope out of all of this, what you're seeing is we have three things. We have identity, we have charge, and then we have mass. So out of these three things, which particles do what? The protons affect what? Protons, all three. All three for the proton. How about for the neutron? Neutron only affects mass. And the electron affects what? Only the charge. So at this point, you should be experts in what each of these particles affect in the atom. All right? Again, proton does it all. Proton is the identity. That's what the proton number is. And the proton number is called what? The atomic number. Oh boy. And the bell just dinged. This is no good. No bueno. I'm going to have to pause this sucker and come back and finish it. This is, oh my gosh. So the proton number is called the atomic number, which it says on the periodic table that I gave you. That's what it says. Now you're also supposed to create symbols in the boxes at the bottom. If you did not do that or did not do that well, I would pause the video now and get on the Build an Atom simulator and click where it says symbol at the very bottom, right next to where it says atom, it should say symbol. Click on that and build yourself a symbol and put the information in the box the way it's supposed to be. Oh no, now they're coming on with announcements. I'll be back in a second. Oh man, that was a close call. Whew! Okay, I need to switch to a new page. Okay, so let me draw a little box here, and then hopefully you will have these things labeled correctly on your paper. Now I'm gonna go with, let's see, how about boron? That's the B. And then let's see, this would be, oh dang. Hold on. Oh geesh. I need red. I got that 5 right there. And then up here, let's just say it's 10. And then over here, let's say it's -1. Now, what is all this stuff in the box? So this thing right here, and you're going to want to write this down if you haven't already. Now this information is in the table I gave you, the periodic table that I gave you the other day. The B is the abbreviation for the name boron, and that has a name. It's called the element symbol. If you look in the lower left corner of that table I gave you, it points to the Mg in that example. For the key, for the legend there for the table, it points to the little Mg and tells you that because that's magnesium they pulled out. And they say that that is the element symbol. That's what this is. This is the element symbol. It's the abbreviated name. Sometimes it's called atomic symbol, other times element symbol, whatever. There it is. Now, this part here, in the lower left corner on the simulator, the lower left corner is the number of, what are those things? The number of, what particles is this? That would be the proton. Yes, hopefully that's what you were thinking. That's the proton, and there are 5. Now, every boron atom has 5 protons, and that number is called the atomic. Did you see it? Did you find it? That's called the atomic number, which is the number of what? Protons. All right. I'll put that in parentheses. Tons. Hopefully you know that. That's the proton number. Atomic number is proton number. Now, on the simulator, this little thing here, what's that? Hopefully you see up in the corner there, you see maybe a scale, I think they show. That is telling you the mass of that particular atom, mass of the atom. So that is the mass number. Darn bells. So that's the mass number. Then lastly, we have this part here. This part here is showing us what? That's the charge. Oh my gosh. They're going to do announcements while I'm in here. So you'll probably hear them on the dang speaker. I guess I could pause it. I'll be back in a second. Okay, here we go. As I was saying, before I was so rudely interrupted, this right here is telling us the charge. So this plus and minus thing, that's the charge of the, oh my gosh, yeah, you got the idea. So that's the charge of the object, or of the atom, I should say. Those are the 4 things that are there. Again, the element symbol, that I didn't write down the name, the atomic number, the mass number, and the charge. Now, if you'll notice, on your table, the atomic number is not on the lower left. It's actually in the upper middle. The mass on your table isn't even called mass number. It's called the average atomic mass, and it's not in the upper left. It's in the bottom middle. If you look at the one hanging on the wall in the room, as everybody's heads turn, if you look at the one hanging on the wall in the room, the atomic number is actually in the upper right corner, and the average atomic mass is in the bottom center. So what this means is that every periodic table you look up, if you look up just images on Google of periodic tables of the elements, you will see many different formats with pieces of information in very different places. There is no one set pattern or template that all of these tables fit. I wish there was. It would make sense if there was, but there isn't. So everybody's got their own little way to put the stuff in the boxes. But I'm telling you, you should be able to look at the box and know which one is the atomic number, because you're supposed to know that boron is number 5. And if you look at the table I gave you, all the elements are listed in order, starting with 1 and hydrogen. They're listed according to their atomic number, the proton number. That is the identifier, and so that is the number used to list them in the order. Starting in the upper left with hydrogen, upper right with helium, then you go to the second row with lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, as you go across from left to right. So that's the way the table is set up. Now, one other thing I want to finish with here. If you'll notice, if you click, go ahead, and if you have to pause the video, you can do that. I want you to get into the simulator, and I want you to click on, I want you to build boron, and I want you to make sure, of course, you have your 5 protons, because that's what boron has. I want you to make a 10 with boron, 10 mass. You can make this neutral. That would be fine. And then I want you to check the stability box, stable versus unstable. I want you to make sure that box is checked, and I want you to see if the 10 is stable or not. Check that, and then come back. Okay, now I want you to see if the 11, drag another neutron in there. That's the way you're going to make this 11 without changing this. Drag another neutron in there to make this 11. See if that's stable. Are you doing that? I hope you do that. Now, hopefully what you have seen now is that there's only 2 kinds of boron that are stable. If you drag a neutron out and drop this to 9, it will not be stable. If you put another neutron in and make it 12, it will not be stable. So the only ones that are stable are boron 10, and this is how it's written, boron 10, and boron 11. Now, these are called isotopes. So you're going to need to write this down. Now, you can write this stuff down on your on the worksheet itself. I don't know if you've been keeping notes anywhere else or if you've just been writing everything down on the worksheets. The worksheets can pretty much serve as your notes for this unit. So, I mean, for all I'm concerned, you can go ahead and write all this stuff on that worksheet, and it is then your notes. So isotope is when you have, let's see, how should I write this out? They are atoms of, oh my gosh, one element. Oh geez. That have different masses. Wow, those S's are terrible. So, there we got that. There we got that. So atoms of one element that have different masses. So what we see here is that we have boron 10, which is stable, and we have boron 11, which is stable. 10 is stable, 11 is stable. 2 different masses, same element. They both have 5 protons, but boron 10 has how many neutrons? Hopefully you're thinking 5, because 5 plus 5 is 10. That means boron 11 has how many neutrons? I hope you're thinking 6, because 5 protons plus 6 neutrons gives you a mass of 11. So they don't have the same mass, but they are the same element. Their characteristics are the same. You wouldn't know that there's two different kinds of boron. If you had a chunk of boron sitting in your hand, and you look at that chunk of boron, you would not know that there's more than one kind of boron atom. Again, the only difference is that one has one more neutron than the other type of boron atom. Now, what I want you to do next, and this is something you're just going to have to think about because I'm not there to continue this discussion. If you look at boron in the table and look at its average mass, the average mass of boron is what? Are you looking that up right now on your periodic table? It's 10.81. 10.81 is the average mass of boron in your table. But I just told you there's two kinds of boron. There's boron 10 and there's boron 11. But the average is 10.81. And so the question is, how on earth do you have 10s and 11s and have an average of 10.81? How can that be the average if all you have is 10s and 11s? Wouldn't 10 and a half, 10.5, wouldn't that make sense? But it isn't, it's 10.81. So I want you to think about how that's possible. How is it possible that boron 10 and a boron 11, that all those together are going to average out to be 10.81? We'll talk about that next time. See ya.